Expectation of xn. So expectation of xn is just summation m is equals to 1 to n, 1 to capital N, m into m to the power of n minus m minus 1 whole to the power of n by n. So this, if we compute, we'll get n by n plus 1 into n plus 1. So this is our expectation of xn. So therefore we can clearly see it is biased. So it is not unbiased. And secondly, like if we find the joint likelihood, from this joint likelihood we can also say that this x of n is sufficient. So therefore the maximum likelihood this thing is sufficient and biased. So now if we consider the completeness, so probability of n when t is equals to m is nothing but probability of t less than or equal to m minus probability of t less than or equal to m minus 1. So that is m by n whole to the power of n minus m minus 1 n by n whole to the power of n. So m to the power of n minus, so in the above one also capital N whole to the power of n. So m minus 1 whole to the power of n by capital N whole to the power of n. So that means if I find the expectation of n, a of t is equals to 0. So this implies summation m is equals to 1 to n, a of m into m to the power of n minus m minus 1 whole to the power of n is 0. Now if we keep m is equals to 1, we are getting a of 1 as 0. So suppose like if we consider a of 1 and so on till a of k minus 1 as 0 and putting n is equals to k in this. So we can clearly see kn minus k minus 1 whole to the power of n is clearly greater than 0. So that means a of k is equals to 0. Hence by induction we can say a of k is equals to 0 for all k. So that means like t is complete statistic as well. So it is complete, it is sufficient, it is not biased, not unbiased. And regarding consistency, if I consider probability of x of n minus this n greater than half is nothing but probability of x of n less than or equal to n minus 1, which is nothing but n minus 1 by n whole to the power of n. So now like as n tends to infinity, clearly this n minus 1 by n whole to the power of n tends to 0. So that means probability of mod x of n minus n greater than half tends to 0. That means x of n in probability tends to this n. So that means x of n is also a consistent estimator. So the maximum likelihood estimator is consistent, sufficient and complete. So option A is the correct answer.